One of the more important topics we're going to talk about this semester is uniform circular motion. So this is as good a time as any to introduce it. So remember that the velocity is a vector. So in other words, something can have the same speed but just be changing in direction. So in other words, let's say we have a particle traveling in a circle. So we look at three different times. So we have v1, v2, v3, and v4. And we say its uniform circular motion is the magnitude of v1 is the same as the magnitude everywhere else on its orbit. So its speed is never changing. The only thing that's changing is its distance, right? So in this case, if we say the magnitude of all of these is just v, then v1 is just v y hat, v2 is minus v x hat, v3 is minus v y hat, and v4 is just v x hat. So again, magnitude is always the same, the actual direction is different, and so because of that it does require an acceleration because the velocity is changing. It's just the speed that isn't. And the acceleration in all of those cases is pointed inward. So and this is true, this is always true for uniform circular motion, is the acceleration is pointed directly inward. So a1 is equal to a2 is equal to a3 magnitude wise. It's a. It's always the same constant magnitude acceleration pointing in. But once again, a1 is not equal to a2, which is not a3, which is not a4, because it's a vector, and again, these are all pointing in different directions, even though it's always toward the middle of the circle. The other thing to know about uniform circular motion is the acceleration is v squared over r. Okay? Since we're breaking this class up into small units, because of the way that we're doing it, we're not really going to give you formula sheets. So there are going to be some formulas that are important that you need to remember, and this is one of those. So remember that for uniform circular motion, the acceleration is the tangent velocity squared over the radius. So r, in this case, is the radius of this circle. It's the radius where that object is going around.